Ever needed to adapt an existing function into an AI tool with smarter defaults, renamed parameters, or validation, without rewriting the original? You'll see how ArgTransform lets you create specialized versions of tools by modifying argument schemas, adding validation, and controlling how parameters are passed to the underlying function. We'll transform the basic add function into a more flexible tool that automatically supplies a default value of 10 for y, while demonstrating how renamed arguments flow through to transform functions via quargs. This pattern is particularly powerful for adapting legacy APIs or adding validation layers to existing tools. From FastMCP, import FastMCP. From FastMCP Tools, import tool. From FastMCP Tools Tool Transform, import ArgTransform. MCP equals FastMCP. At MCP, tool. Def add x, int y, int. Adds two numbers. Return x plus y. New tool equals tool from tool. Add. Transform args equals. Y, ArgTransform default equals 10. This demonstrates the tool transformation pattern, a composable approach for adapting existing functions into specialized variants through declarative metadata rather than code duplication. The pattern enables argument renaming, default value injection, validation layers, and schema modifications while preserving the original implementation's core logic. Its distinctive power comes from treating tools as configurable interfaces that can be transformed for different contexts without altering the underlying business logic. The transformation works by creating wrapper tools that intercept calls, apply schema changes through ArgTransform configurations, and forward arguments to the original function. When using transform functions, renamed arguments arrive via quargs with their new names, not original names, with forward, handling the mapping automatically while forward draw bypasses transformations for direct access. This design maintains type safety through Python's type system while enabling runtime customization of tool interfaces, validation logic, and even output schemas. This pattern excels at API adaptation scenarios, particularly when integrating legacy systems, exposing client libraries as tools, or tailoring interfaces for AI consumption. The ability to rename confusing parameters, hide internal arguments, add validation, and modify schemas through configuration rather than code makes it ideal for creating clean, context-specific tool variants. The pattern scales especially well when combined with MCP config transformations for server-wide tool customizations. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI-callable tools. It handles function registration, argument validation, and execution while maintaining type safety through Python type hints. The class also supports tool transformation patterns for API adaptation and legacy system integration. Key capabilities include argument renaming via ArgTransform, name equals new name. Default value injection without modifying original functions. Validation functions during transformation, like ensure positive. Both sync and async transform support. Configuration transformations via MCP config. Transformed arguments are passed to functions via quargs using their new names, not original names, enabling clean API adaptation while preserving core logic. The pattern is particularly valuable for creating specialized tool variants without code duplication. From FastMCP Tools, import tool. Imports the tool class FastMCP's core abstraction for creating modified variants of existing tools. This enables three key transformations: setting default values via ArgTransform, default equals value, renaming arguments with ArgTransform, name equals new name, and adding validation functions like ArgTransform, validate equals ensure positive. When transform tools execute, their arguments arrive in quargs using the new names, not originals critical for forward versus forward draw handling, where forward expects renamed args while forward draw receives originals. The pattern excels at API adaptation, legacy system integration, and can include async transform logic.
From FastMCP Tools Tool Transform, import ArgTransform.
This imports ArgTransform, FastMCP's utility for runtime argument modification, enabling default values, validation, and renaming without altering the original function. Transform functions receive renamed arguments via quargs, with forward preserving the transformation and forward draw using original names. The pattern supports async transforms and is ideal for API adaptation and legacy system integration.
MCP equals FastMCP.
Instantiates the central FastMCP controller that manages all AI callable tools. This is the entry point for tool registration, schema management, and execution coordination between Python functions and AI models. The instance handles argument transformation, validation, and proper type hint propagation to the AI interface.
At MCP, tool. Def add x, int y, int. Adds two numbers.
The @MCP tool decorator exposes this function to AI models while preserving Python type hints for validation. FastMCP converts the docstring and type annotations into a structured schema that AI systems use for discovery and input validation. This establishes the base tool that tool from tool will modify. The transformation pattern creates specialized variants without altering the original function, maintaining a single source of truth while adapting interfaces for different use cases.
Return x plus y.
This performs the actual computation that the AI tool exposes. The function takes two integers and returns their sum, implementing the core business logic while delegating argument handling to FastMCP's transformation system. When called through the transformed tool, arguments arrive as keyword arguments using their new names, not the original parameter names. This enables clean argument renaming and default value injection without modifying the base function.
New tool equals tool from tool.
This creates a transformed tool variant using FastMCP's argument transformation system. The fromTool method clones the original add function while applying schema modifications, here setting a default value for y without altering the base implementation. Transformations support argument renaming via ArgTransform. Name equals new name, value validation through custom functions, and both sync-async transform logic, with transformed arguments passed via quargs to maintain clean separation from original parameter names.
Add.
Passes the original add function to tool from tool for transformation. This creates a modified variant while preserving the core logic, enabling argument renaming via ArgTransform. Name equals new name, default values, and validation rules. Transformed arguments are passed to the function via quargs using their new names, not original names.
Transform args equals.
Transform args enables argument transformation, validation, and renaming for tool interfaces. It lets you modify parameter schemas without altering the original function, supporting default values via ArgTransform default equals. Argument renaming with ArgTransform, name equals new name, and validation through custom functions. Transformed arguments are passed to the underlying function via quargs using their new names, not original names, with both synchronous and asynchronous transform functions supported.
Y, ArgTransform default equals 10.
This sets a default value of 10 for the y parameter using FastMCP's argument transformation system. The transform modifies the tool schema without altering the original function, enabling API adaptation and legacy system integration. Transformed arguments are passed via quargs to the underlying function, with forward receiving renamed arguments while forward draw preserves original names. This closing brace completes the argument transformation configuration, where ArgTransform enables 3 key modifications: setting defaults, renaming parameters, and adding validation. The transformed arguments are passed to tool functions via quargs using their new names, not original names, with forward receiving transformed values while forward draw gets original inputs for cases needing raw argument access. This pattern excels at API adaptation, letting you modify tool signatures without changing core logic, while supporting async transform functions and MCP config-level transformations for server-wide argument handling. This closing parenthesis finalizes the tool-from-tool transformation, creating a specialized version of the add function where y defaults to 10. The pattern enables argument renaming via ArgTransform, name equals new name, validation through custom functions, and supports both sync-async transform logic, all while preserving the original function's core implementation. Transformed arguments are passed to forward-forward raw methods via quargs using their new names, not original names, making this ideal for API adaptation and legacy system integration. Tool transformation pattern. The ArgTransform and tool-from-tool pattern enables precise control over tool interfaces by renaming arguments, adding defaults, and injecting validation, all without altering the original implementation. Transform functions receive renamed arguments via quargs, so you must use forward, not forward draw, to maintain consistency with the transformed schema, as the quargs contain the new names, not the originals. This pattern excels at API adaptation, where you might rename X to A and Y to B while adding validation like ensure positive or defaults, like ArgTransform default equals 10. The same transformations can also be applied declaratively via MCP config when running servers, bridging runtime flexibility with configuration-driven consistency.
The tool that never changes its code becomes every tool the client needs.